everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, do let me know in the chat box if I am clearly visible and audible to all of you or not. Yes everyone, in the chat box, do let me know if I am clearly visible and audible to all of you or not. Yes students, very good evening. Okay, hi Anuradha. Hi Visha, Abhinav, Rejo, Suman, Usha, Rama Raju. How are you all? Very good evening everybody. Very good evening. So till now guys, we have completed GOC, right? Everything related to GOC, stability of intermediates, acidic basic strength, every single thing we have done on this channel, right? Now the last chunk of basics of organic chemistry under the GOC is isomerism, right? Now isomerism I have divided into three parts, right? First is we'll discuss about, in today's lecture we'll discuss about structural isomerism, right? What are the different kinds of structural isomerism. Then we'll talk about geometrical isomerism, Cis-trans, EZ, anti-syn, all these things we are going to talk about in today's lecture. Right? Once we are done with that, in the next class we are going to move towards optical isomerism and then conformers, right? So this is a whole thing of isomers and it's a very important topic regarding your JEE preparation. Very important. They can ask you these questions directly also. I'll show you PYQs also, that how previous year questions they are asking you continuously, like very simple basic PYQs they ask, questions they ask from this particular topic, right? So for that we'll go with the flows, but you have to be like very consistent and you have to have patience so that you watch. It's not like you watch the only first lecture, ma'am, today's lecture ma'am I have watched, nothing will happen. Today's lecture, next lecture and next to next lecture. 3 lectures combined is going to complete your isomerism, right? Okay. Now everybody, let's start that without wasting any time. But before that, let me tell you about MVSAT scholarship program, which is going to happen just now on 4th, 5th, 11th and 12th of October 2025. Registration is completely free of cost. You don't even have to pay a single penny. But in returns, after giving the test, you will get iPhones, iPads, 2 crore worth rewards and cash prizes you will get, and moreover 150 crore worth of scholarship, that is 100% scholarship on all the Vedantu courses is what you are going to get, right? So it will be like really stupid thing if you miss on this particular scholarship program, right? Visit your nearest offline center and give this test and you will be sorted, right? Okay, yes. So let's see everybody. Let's start with isomerism, right? So isomerism, just like we discussed in coordination isomerism as well. In this case, isomerism is actually when you have same molecular formula, molecular mass is same, molecular formula is same, right? But the arrangement of the atoms is different here. That is called isomerism. Now, isomerism is divided into 2 categories. First is structural isomerism. Structural isomerism. Second category is stereoisomerism. Stereoisomerism. Now, in case of structural isomerism, what will happen? The linkages will be different, right? That means maybe one you have RCHO, other you will have RCOR. These are structural isomerism. When we are not talking about the spatial arrangement, we are saying that the attachment of atom is different here. That can be further divided into so many parts, right? The attachment of the atoms is different in this case, right? But in case of stereoisomerism, the spatial arrangement of the atoms is different, right? So you can have only one compound, but we need to see how this compound is spatially arranged into different parts. That is called stereoisomerism, right? So structural isomerism is the arrangement of atom is different, or you can say simply attachment of atoms. Attachment of atoms is different, of atoms is the differentiating part here, and here spatial arrangement is different, right? In space, whether it is forward, backward, like so many things will be there, mirror images is formed or not, based on that we are going to discuss about stereoisomerism. That is, arrangement in space is different. Arrangement of atoms in space. In space, how it is arranged, that is different in this case, right? So that is the difference of structural and stereoisomerism. In today's lecture, firstly we are going to focus on structural isomerism, right? So let's talk about structural isomerism. This I have already told you. Now guys, in structural isomerism, it is also called as, it's another name of structural isomerism is constitutional isomerism. So they can also confuse you by giving it in the question that which of the following is constitutional isomerism. So if they say constitutional isomerism or structural isomerism, that is same thing, right? So you can also say structure, you can also say constitutional isomerism, right? Now let's talk about the different types of structural isomerism that you have. One by one we are going to look forward what are all these different kind of isomerism. First is chain, then there is position, functional, ring chain, metamers and tautomerism, right? And out of these, the maximum questions that are asked is from metamers, right, that they ask you. Then highest probability is of tautomerism. This is the most important, right, among this, that is tautomerism, right, that we are going to discuss here, right? So chain, position, functional, ring chain isomerism is very simple, right? So let's go through that. Firstly, what is chain isomerism, right? Let's understand that. Yes, everybody? What happened? Nothing happened. Oops, I forgot to upload it now. It is in my laptop only. Today, I promise I'll upload it today. Okay, I promise I'll upload it today, right? Okay, so now everybody, let me know what is chain isomerism, right? You have discussed the IUPAC naming with me. Now in the IUPAC naming, we used to select the longest chain, right? So chain isomerism, the longest chain, if it has different number of carbons, right, then it will be called as chain isomers. Let's take an example. Same molecular formula but different parent chain. That means the number of carbons in the parent chain is going to be different in this case. Let's talk about that, right? This is an example. If you see this here, it is 1, 2, 3, 4, 5. This is 5 carbons. This is 1. You will start it from here. 1, 2, 3, 4. And here it will be 1, 2, 3. Right? So if you see this is 5 carbons. This is 4 carbons. This is 3 carbons. So the number of carbons in a parent chain are different. That means this is considered as chain isomers, because the parent chain has different number of carbons here, right? Otherwise the molecular formula is same here, right? Okay everyone, right everybody? Okay, now let's understand this part here. Then there is this question, tell me if it is under the category of chain isomer or not. Yes everybody? Let me know if it is under the category of chain isomer. I'm a state student. Can I study JEE and clear it? Yes, definitely. Who is saying that state board students can't clear JEE? Who is saying that? Who is giving you these kind of, demotivating things, right? That is definitely not true. In fact, state syllabus is like really good level syllabus, right? It is actually a tough exam as compared to if you talk about CBSE, right? But yes, it doesn't matter which board you are from. You can be from IB board, ICSE board, but if you don't know the core concepts, if you don't know how to solve JEE questions, you can't crack it, right? So for cracking JEE preparation is needed. Doesn't matter whatsoever is your board, right? So get this thing clear into your head, It has nothing to do with your board. Your basics has to be very strong, right? Okay, so this is A, this is B. If I see 1, 2, 3, 4, 5, and here it is 1, 2, 3, 4, 5, 6. Can I say the longest chain is different? That means it is definitely under the category of chain isomers. I can say this is under the category of chain isomers. So that is the correct option here. Next is position isomers. Next is position isomers. How do you answer position isomer? Same molecular formula. Parent chain is also same. But position of branch or the functional group is different here. Right? Let's see an example. If you see this question here, this is 1, 2, 3. Just do the numbering firstly. This is 1, 2, 3. Can you see parent chain is also same, molecular formula is also same. You have 3 carbons, 1 OH, 3 carbons, 1 OH. Molecular formula is also same, right? Parent chain is also same. But here this is on first position you have ol. Here on the second position you have ol. So definitely they are isomers of each other. They are not, this is not the same compound. Here molecular formula is same, molecular mass is same, but that is a different compound, right? Because the position of OH group is different here. So that's why this will be considered as position isomers, right? Position isomer, right? This will be considered as position isomer. That is correct. Now let's talk about this one, right? Here you have to consider longest, that is 1, 2, 3, 4, 5, 6, right? Here you have to consider 1, 2, 3, 4, 5 and 6. Can you see here it is on first and second position, here is it on first and third position. So definitely one chlorine is at different position. That means this substituent is at different position. So I can say this is also under the category of position isomers. Okay, yes everybody, this is also under the category of position isomers. Is that clear to everyone? Is that clear to everyone? Now let's understand this more, right? Let's understand this more. If you talk about this one, right? Here again it will start from 1, 2, 3, 4, 5. Here it will start from 1, 2, 3, 4, 5. So obviously parent chain is also same. This is 1, 2, 3, 4, 5, 5 carbon. This is also 5 carbons. 1 double bond O. 5 parent chain is there. That means, can I say that here this is also position isomer. This is also position isomer. How come it is a position isomer? Because here it is on the third position. Here it is on the second position. This is pentane 3-one. This is pentane 2-one. Right? So that means the position is different here of the functional group. So this is also different. Now let's talk about this one. Here it will be 1, 2, 3, 4, 5, 6. Okay? Right? 1, 2, 3. Yes. Here it will be 1, 2, 3, 4, 5, 6. Now can you see the position of bromine is different. Here the position of bromine is on the 5th position. Here it is on the 4th position. Everything else is same here. So that means here also it is position isomer, right? But before telling that this is position isomer, you have to confirm that this is not a parent chain, right? If the parent chain is different, it will be considered as chain isomer, right? So here parent chain is same, that's why it is called as position isomer. Now let's talk about this one. This one is very important. Let's talk about this, right? This one is quite important, guys. So let's talk about this. Yes, everybody. Thank you so much, Ankit. Thank you so much. Right? Great. Very proud of you. Ma'am, your classical example COH, right? It has to be there when I am talking about, it's a scam guys, it's a scam, okay? Beware of this scam, right? Okay, Ankit, I'm very proud of you. Awesome, awesome, awesome. Very proud of you. Right? Yes. Yes, everybody. Now let's see if you can answer this. Now, whenever you actually number, that's why I was always numbering the parent chain. When you look at this once, you'll say, ma'am, 1, 2, 3, 4, 5, ma'am, 1, 2, 3, 4, 5, ma'am. Position of COH is different. But do you remember that whenever you have a carbon in the functional group, it starts from the COH, right? It starts from the COH. So here it will be 1, 2, 3, 4. This is going to be 1, 2, 3, 4, 5. So can you see what is happening here? Can you see what is happening, guys? Can you see what is happening here? So here the parent chain is different. It is a chain isomer. So that is what I told you, that firstly you have to confirm whether the parent chain is same or not. Here the parent chain is only different, guys. Just give me a second. Hello. Yes. Yeah, I'm feeling a little bit pain in my neck. I don't know why suddenly I'm feeling that. Right? Okay. So this is the chain isomer that we have. Right? Right? This we have done. Now let's talk about this one. Let's talk about this one. If you see this here, can you see this is A and this is B? Who will tell me about it? Who will tell me about it? This is A, this is B. You can see 1, 2, 3, 4, 5. Will you do it like this? No, ma'am. It is a CHO group, ma'am. It will start from CH. 1, 2, 3, 4. It will start from here. 1, 2, 3, 4, 5. So it also is going to be chain isomer, right? It also is going to be chain isomer. I am fine. I am absolutely fine, guys. I am absolutely fine. Don't worry. Right? So now let's talk about this one. This is, let's see if this is position isomer or not. Tell me. This we have done before. Today only we have done this. What kind of isomer this is? Yeah, actually I was fine only before the class, to be very frank. I don't know what has happened just now. I think the AC is too high. I don't know what is happening. In between the class only I am feeling a little bit pain. Oh. Okay. Actually some cervical issues I have. So that's why sometimes I feel I don't know why suddenly out of nowhere I am feeling little bit pain. Chalo, no issues. I need to distract myself, and that I'll do by teaching you, right? So this is 1, 2, 3, 4, 5, and here you will have on the third position OH, here it is on the second position OH. So it is going to be position isomer. Ma'am, why have you not started it from OH? Because whenever we number OH, we never had this condition in IUPAC naming. If you have a carbon containing, and that too terminal carbon containing functional group, there it will start from terminal position. Okay? Thank you, thank you, thank you. When your love is here, then why Diksha Ma'am will fear? Tell me. Nothing to fear if you guys are here, right? I know that your best wishes are with me, and I know that your best wishes will keep me going. I know that, right? So that's why whenever I fall ill, I get up. When I fall ill, I get up, because I know you guys are with me, and because of your motivation, guys, I have started a little bit weight training and yoga also, because so many students advised me, ma'am, that you suffer a lot from this pain. You should invest your time in your health also. So that's why I think I have started, and recovery always takes time. Your body, you can't heal it in one day, right? Your body it will take some time to get healed, right? So that's why I tell you, now your body is in your hands. I have done that mistake. When I was of your age, I always used to study. I don't know how I developed cervical and how, it aggravated a lot. But now I advise all my students, please, study is very important, but please take care of your health as well, because health never comes back. Never comes back. This is very important. Study, walk a little bit, because that is the mistake that I have done. When I was of your age, I never used to walk, I never used to do any exercise. I always used to feel like, I am not fat, then why I have to work out, right? But now I realize you don't have to work out because you have fat on your body or something, right? You might seem very, like, to everyone, they're like, okay, you are slim, trim, why you need to, do these weight training and all. But for your body strengthening, you have to do it. Either ways, we are eating adulterated food only. At least what we can do is, we can do a little bit exercise. That's what I have realized over the last 10 years, and that's my advice to you, right? All you can do is walk a little bit while you're studying, right? Because these issues are developed only when you are, struggling a lot in your studies, right? Chalo. Now let's talk about metamers, right? Now let's talk about metamers. Metamers have same molecular formula. The molecular formula is same. Different alkyl chains on both sides, and it is shown by bridging groups. It is shown by bridging functional groups. Bridging functional groups, like you have R, in which on both the sides you have functional groups. Both the sides you have alkyl chains. Like you have ether, like you have ketone, like you have ester, like you have this R, S double bond, O, R dash, right? So these are the groups, right, that are creating bridges here. This R and R dash has to change to convert it into metamer. Let's see the example here. Let's see, these are the two examples. So if you see, this is CH3, on one side it is CH3, here also on one side it is CH3. Here on one side it is CH2, CH3, here also on one side it is CH2, CH3. So this is not metamers, not metamers. They are not metamers. We are not saying that this R will interchange the place. We are saying the alkyl group will itself change. So they are not metamers. But if you talk about this case, here if I want to draw the metamer, what I can do, I can draw CH3, O, CH2, CH2, CH3. Now here both you have ethyl groups, and here one is methyl and one is propyl. So that means the alkyl chain has changed here, right? In that way, there is another metamer that is possible for this one. Another metamer that is possible is, this is CH3, CH2, this is CH2. Another metamer that is possible here can be this one, right? But this is giving you a ring also here, right? Another metamer that is possible can be this one also. Another metamer that is possible can be this one also. Okay, it can be this one also. CH3, 2, 3, it will be H here, right? Yes, it can be this one also. You can also write it like this. So these are the metamers that are possible, right? Okay, ma'am, video is not clear. Is video not clear, everybody? Tell me. Is video not clear? Yes, blacklisted. What do you think? My natural hair color is this? No, it was never. And I literally, some decisions in life that you regret. This is one of the decisions that I regret in my life. Why I had this, like, I want to color my hair. Now I literally hate this color of my hair. I was like, I love the black color. Like, oh God, right? Do you really think that this is my natural hair? No, guys, my natural hair is way pretty. This is like literally, I don't like it at all, right? So alkyl chains are different here, right? Okay, yes. Now this we have done. I think I'll just delete this one also. Next is functional isomers. It has same molecular formula but different functional groups. Okay, so let's see. For example, alcohols and ethers. For example, you can have ROH and ROR. For example, you have CH3CH2OH and this will be CH3OCH3, right? You can also write it like this, and CH3OCH3, right? But if you say, ma'am, can I have functional group isomer of CH3OH? Not possible, right? Because here ether formation is not possible. For ethers you need 2 alkyl groups. This is only 1 alkyl group. So that is not only possible here, right? Okay, so that's why for CH3OH it is not possible. It is not possible to draw the ether here, right? Rest of it you can draw the ethers, right? Next is acids. Acids like you have RCOH and RCOOR. Example, you have, let's say, CH3CH2 COOH and you have CH3COO-CH3. This is an acid, this is an ester, right? So, 2 isomers with same molecular formula are possible here, right? Then you have cyanide isocyanide. Cyanide isocyanide means RCN and RNC. This is cyanide, this is isocyanide. Here, so you don't even need to, worry that much about this. CH3CN or you have CH3NC. So, to from where it is connected. So, this is going to be cyanide, and this is going to be isocyanide. Okay. These are also functional group isomers. Next is ketone. If you see RCOR and you have RCHO, right? RCHO, that is the thing. Okay, now see this thing, okay? Now see this thing. This is RCOR and this is RCHO. Here, let's say you have CH3COCH3. This is ketone. And to make with the same molecular formula, I might want to make a aldehyde. So, it will be CH3CH2CHO, right? So, they are also isomers of each other. That is functional group isomers, right? Next is ring chain isomer. What is a ring chain isomer, everyone? What is a ring chain isomer? A ring chain isomer is in which we know that the formula of alkene is CnH2n, okay? And formula of cycloalkane is also same. Cycloalkane is also same. So that means if I want to draw this thing and if I want to draw this thing, if you see, they both will have same molecular formula, right? This will be CH2. I can also draw it like this, CH2, CH2, CH2. This is the cyclopropane ring. So, this is 3 carbon, C3. This is nothing but C3H6. This is also C3H6. So, can you see cycloalkane with no double bonds, no pi bonds, simple cycloalkane with the corresponding alkene with only one double bond, right? Anywhere but only one double bond. will have the same molecular formula, right? That's why they are, yes, very good. This is not aromatic, bacha, this is not aromatic. Again, no beta, this is not aromatic. Aromatic always have double bond, pi bond, cyclic conjugation is there. This is simple cycloalkane, not at all aromatic, this is non-aromatic. Okay, yes everybody got it? So they both have same molecular formula, that's why they are having ring chain isomer. This is ring and this is chain. So ring chain isomer they have, right? Okay everyone. Now let's discuss if you can answer the questions that I'm going to ask you now, right? Let's see if you can answer this or not. After this we are going to start with Tautomerism, okay? But before that you have to answer this, right everyone? Which type of isomerism do they show? Now this is the question, you need to answer which type of isomerism. First thing is always calculate the parent chain here. So this will be 1, 2, 3, 4, 5, 6, 7. This is going to be 1, 2, 3, 4, 5, 6 and this is 7 carbon. So that means molecular formula is same, right? But parent chain is not same. That means they are chain isomer. Very good. They are chain isomer, right? Next is, this is chain isomer. Next is, now if you talk about this one, what type of isomerism do they show? Yes. So if you see here, this will be 1, 2. This will be 1, 2. But can I see molecular formula is same, parent chain is same, but the position of this one OH group is not same. This is on one position, you have 2 O's, this is on 2, this is basically geminal, this is geminal, diol. That we'll discuss further. What is geminal? When on the same carbon you have 2 OH. This is vicinal. This is vicinal diol. When on the adjacent carbons you have OH, right? That is vicinal OH. Very good. So that is going to be position isomers here because the position of OH is different here. Next question, if you see this here, tell me, are they position isomers? Are they chain isomers? Right? Yes, everyone. What is this one? Yes, very good. Very good, very good, very good. Yes, everyone. So if you see this here, we need to draw it. 1, 2, 3, 4. This is basically, one thing is, I want to see what you answer here. Abhishek is answering functional group. What about other? What about others? Geminal and vicinal. Suganti, let's ignore vicinal and geminal, right? Because we are going to do that eventually in alcohol, phenols and ethers, right? But still, if by just one line, if I can teach you, when on one carbon you have 2 OH, that is on the same carbon you have 2 OH, that is geminal. When on the adjacent carbon you have OH, that is called vicinal. Okay? That is a mistake that you are doing. With position isomer you are saying. Okay, tell me one thing. Is the chain same? 1, 2, 3, 4. This is also 1, 2, 3, 4. But can I see this is CHO group and this is ketonic group? So position will be same if the functional position, we can only say if the functional group is same, right? This is aldehyde. This is aldehyde. So the functional group is changed here. So it is going to be functional isomer here, right? This is not a position isomer. This is a functional isomer because the functional group is changed. Very good, Rama, Raju, and who else? Very good, Abhishek. You both have given the right answer. Right? Very good. Right? So it is going to be functional isomer. Next is, okay, tell me about this one. Let me see who can answer. Let me see who will answer this. Let me see who will answer this. Firstly, please see whether the parent chain is same or not. Number of carbons in the parent chain, firstly you have to remember that. Number of carbons in the parent chain is what your first task is all about, right? Yes, everybody? Number of carbons in the parent chain is what your first task is. Let's talk about that. So here it is 1, 2, 3, 4. Here it is 1, 2, 3. They are not even isomers. They are not isomers only. Forget about chain, position, functional. They are not even isomers. So that also you have to see first. Yes, you can't say chain because here they are not even, they don't have same formula. Right? They don't have same. Here you have C3. Here it is C4. So formula is not same here. So they are not even isomers of each other. What about this one? Which kind of isomerism is shown here? Here in the bridging group, the alkyl chains are different here. Can we say the alkyl chains are different? So we can say these are metamers of each other. These are metamers of each other. Right? Okay, understood. Now next very important part, we are going to start with tautomerism, but before that let me know in the chat box if there is any problem till now. Let me know in the chat box guys if there is any problem till now. If there is any problem till now, do let me know in the chat box. Okay. Yes, Abhishek, Yashwant, Harini, Rama Raju, right? Yes. Ready? No problem. Okay, let's talk about tautomerism now, which is a very important thing. You will use this even throughout your chemistry, organic chemistry. There will be reactions where tautomerism is used, like Kirchhoff's reaction is one of the reaction where we use tautomerism, right? So many reactions, that's why understanding this part is very important for you, right? So let's understand this. First is, what are the other names? This you can remember, you can ignore also. This is just for your knowledge. I have written cryptotropism, allotropism, destotropism or prototropism is also called tautomerism, right? So these are the different names of tautomerism what you have, right? So firstly, let's understand the conditions, right? Conditions, you might feel, ma'am, the conditions are similar to hyperconjugation, but hyperconjugation and tautomerism are not at all similar, right? They are different concepts, right? But the conditions are quite similar. So first thing is, alpha carbon should be sp3, right? So for example, I am talking about keto, right? So this is the carbon and here this is alpha carbon, this is alpha carbon. So first condition is alpha carbon has to be sp3 hybridized, okay? It should have 4 bonds, right? Only then we can say it is sp3, right? Then alpha carbon should have at least 1 hydrogen here. At least 1 hydrogen, right? On any alpha position, even if you have one single alpha carbon, right? Even let's say here you don't have alpha carbon, here you have alpha carbon which is sp2. Then if in this particular case it is sp3 and it has 1 hydrogen, then from this particular site it will show tautomerism. Because tautomerism is actually H positive transfer, and that H positive transfer will be from the alpha carbon which is sp3 hybridized. That is the condition. Okay. Alpha hydrogen now. Yes, at least one alpha hydrogen should be there, right? Yes. Now, let's talk about this one. Now, you have to tell me what exactly is a simple way of doing tautomerism, right? Firstly, find out alpha carbon, which is sp3. Both are alpha. This is the main. So, this will be alpha, this will be alpha. This is also sp3, this is also sp3. Now, you can choose any of them which will tautomerize, right? So, what I'll choose this alpha carbon. Let's say this hydrogen is being shifted. So, what you will do, you will put here 1, 2 and 3. So, simple rule is break the bond of 1 and 2. I'll just write it as it is. This is H, this is H, this is H, C double bond O, this is C, this is H, this is H, this is H. We are saying break the bond of 1 and 2 and have a double bond on 2 and 3. Okay, so this bond will break and this new bond will be formed, right? And this hydrogen will be transferred. Hydrogen will be transferred from third position to first position, that is this one, right? Now, if you see, this was your keto because this is ketone. So, this is called as keto form. This is called as keto form. And here this is ene, that is alkene, and this is ol. So, it is also called as enol form. It is called as enol form. Okay? Yes, everyone? Right? Start with my lectures. It is from basic only, right? So, is that clear? This is keto and this is enol form. Understood? Keto and enol form. If you have any problem, then I can do it again. Do let me know, because in the next 20-30 minutes, we are going to do tautomerism only, various types of questions, PYQs based on tautomerism, right? So, you have to be very good in this, right? So, basically what exactly has happened here, if you see ma'am, what exactly has happened here? What has happened here, this bond has shifted here and this, not this bond has shifted here, this bond has shifted here and this hydrogen has transferred to this particular place, right? Because this is more electronegative, this is less electronegative. So, this pi bond will break and the pi electrons will shift here and here you will have negative. That's why this hydrogen will transfer here to this negative and this particular bond between C and H will shift here as pi bond, and that's how you have this, right? This is the main criteria, but easy way to understand this is just write 1, 2, 3, break the bond of 1 and 2, attach to 2 and 3, shift third hydrogen to first one. It's a very simple way, right? Okay. Now, if you see here, hydrogen is shifted from third to first position. So, it is also called as 1-3 system, right? Because the tautomerism that we are showing is between the shift of hydrogen is from third position to first position. So, it is called as 1-3 system. Guys, let me know in the chat box if that is clear to all of you or not, right? Okay. Now, this we have done and this is 1-3 system also, I have told you about it, right? Now, see one thing. This is a rule that you need to remove double bond of 1 and 2, add it to 2 and 3. Now, here, actually 1 and 2, 2 and 3, yes. Take H positive from alpha carbon to oxygen, or you can say from third to first position. Right, from third to first position, you have to take the hydrogen from there. This is the rule that you have to remember for 1-3 system. Okay. Now, let's understand which of the following will show tautomerism. Okay. So, I am going to write A, B, C, D here. Let's see if you can answer this or not. Try to answer two conditions I have given you. This is A, this is B, let's say this is C and this is D. Okay, which will any of these show tautomerism? So, always you will have a double bond O, this will be double bond O here, right? You will have a double bond O here, right? This is alpha, this is alpha, here this is alpha, this is alpha, here this is alpha, this is alpha, here this is alpha, this is alpha. Now, let's see whether the alpha is sp3 where? Here it is sp2, so it will not show. Here it is sp3, so it will show. This is sp2, so definitely it will not show. This is sp3, it might show. This is sp3, it might show. This is sp3. Whenever you have a double bond, that means it is sp2, okay? This is sp3, it might show. This is again sp3 and this is again sp3. Right? Now if you see here, right, this is so definitely not showing, right? This is not, no, this is actually possible. This is sp2. How come I have written it as sp3? This is also sp2. So this will also not show. This alpha will also not show. This is also not possible. So here D will not show because both alpha are sp2. Condition is ruled out here. Here this has a chance. Now we need to see whether this has any hydrogen or not. So yes, to complete the valency, it will have 2 hydrogens, so it will show tautomerism, right? What about this one? Here it is sp3, but it does not have any hydrogen. 2CH3, here CH3 group is attached. Here CH3 groups are attached. That means no alpha hydrogen, no alpha hydrogen. So again it will also not show any tautomerism. Here this has to complete the tetravalency 2 hydrogen, this has to complete the tetravalency 2 hydrogens. So this is also going to show. So answer is going to be A and C will show tautomerism, right? Okay, yes everybody, is that clear? A and C, how it is going to show you tautomerism. A and C, I consider this as C, this is B, A, B, C, D. Okay, A and C is showing you tautomerism, right? Okay everybody, do let me know if that is clear. It is not going to show, this is not going to show, this will show, this will show, right? Okay, yes. So this I will delete only because I have taken A, B, C, D different, right? Now you have to draw the enol structure of the following, right? Let's see if you can draw it or not. Right? Let's see if you can draw it or not. So enol structure, first major task is this is 1, this is 2, this is 3. First you have to see whether it will show or not. So this is also alpha, this is also alpha, both are sp3, both have alpha hydrogen, so this will show. So now take this as 1, this is 2, this is 3. Now guys, if you see this here, this is 1, 2, 1, 2, this is double bond O, right? What I told you, break the bond of 1 and 2, break the double bond of 1 and 2 and attach that double bond to and attach that double bond to 2 and 3. So that double bond will attach to 2 and 3. This is 2 and 3, so I will attach this double bond to 2 and second and third position. Okay. Now the hydrogen that you must have here will be shifted to first position, right? Here obviously you will have 2 hydrogens here, 2 alpha hydrogens you will have to complete the tetravalency. So it will be shifted here. And here this is going to be the enol form. This is going to be the enol form and this is under tautomerism, right? Yes, this is 1-3 system, 1-3 system, right? I'll also tell you there are other systems as well, but till now we are talking about only 1-3 system, right? Okay, yes. Now let's talk about this particular tautomerism. Enol structure of this one. How do you draw that? This is 1, 2. Can I take this as third? No. Why? Because this alpha is sp2. So tautomerism in this case is not possible. So I will have to take this alpha. So that I will take as third. This I will take as third. So it will be 1, 2, 3. Now everybody tell me what is going to be the, this double bond will remain as it is. Now break the bond of 1 and 2, shift double bond here, right? And here what you will do, you will shift 1 hydrogen from here. and this is going to be your enol form. Enol form, that is under Tautomerism, and that is 1-3 system, right? Okay, yes. On the left side it will do very good, very good, very good, right? Okay, everybody, understood? 2, 3, break the bond of 1 and 2, shift it to 2 and 3, shift the third hydrogen to first position, right? That's a simple rule that you have to obey here, right everyone? Okay, let me know in the chat box if that is clear, right? Now let's talk about 1-5 system, right? Now let's talk about another system, that is 1-5 system. What are the conditions when it will obey 1-5 system and how it will obey 1-5 system, right? Okay, ready everyone? Okay, let's talk about 1-5 system. See, 1-5 system is only possible, right, when third carbon is sp2, right? Okay, tell me one thing. If you failed your exam, right, and you failed because let's say you have not done enough hard work, right? The problem was from your side. Then you can improve it in the next go, right? If you have done like all your hard work you have put into that, there is some problem from the other side, right? That means maybe there is some kind of corruption that is going on, things are going on like that which is not under your control, or maybe your health is not fine, maybe your medical certificates are not fine, that is under not your control, right? Then even after taking 1 year drop, because your medical health is not fine, so you can't proceed with it, right? So that means there is a condition of improvement. If your health is not fine, your health is not allowing you, right? Then you can't, just ignore your health like that. So there is a condition that you can only improve if your hard work was less, and you can do more hard work into it if your health is allowing, right? So that is the condition for improvement. Here also there is a condition of improvement. Why the system has failed, that depends. Now if you see in this case, this is alpha, this is alpha, this is sp2, this is sp2. 1-3 system will not work here, right? If you see this here, this is alpha, this is alpha, this is sp3, this is also sp3. But can you see in this case, there is no alpha hydrogen. Here also no alpha hydrogen. So 1-3 system is not shown by either this case or this case. Both are not showing you 1-3 system. Here this is failing because the third carbon is sp2. Here this is failing because the third carbon is not having hydrogens. So when you don't have hydrogen, you can't do anything, you will not go beyond it. But yes, if the alpha carbon is sp2, then you will think about 1, 2, 3, 4, then you will see the fifth carbon. But in this case, no 1-5 system is applicable. No 1-5 system is applicable. Here 1-5 system is applicable. Here fifth carbon, you will see that fifth carbon is sp3 and it also has alpha hydrogen. That means Tautomerism will be shown, and that is under the category of 1-5 system. That is under the category of 1-5 system. So to be clear on that, 1-5 system is, right? Oh, don't worry, you don't have to take drop because you are giving your 100%, right? You don't have to take it. I was just giving an example that if you fail, right? Anyone fails, right? Now, if they will recover or not, that depends upon so many conditions, right? So here also it will recover or not, it will depend upon why it has failed, right? So here it has failed because of sp2, then it can go beyond 1-5 system. But if it has failed because of alpha hydrogen, then it will not show 1,5 system. Is that clear, everybody? This case I'll also show you, then you will say, ma'am, why you are saying this, ma'am, why this is so? That also I'm going to show you. But firstly, just remember this thing, right? Okay. Now, if 1,3 system fails due to presence of sp2 carbon, only then look at 1,5 system. If it fails due to presence of sp3 carbon with no alpha hydrogen, then 1,5 system is not at all observed, right? You have to be clear why it is failing. Now, let's see how do you do the tautomerism of 1,5 system and why sp2 is required, why not sp3. So, write it 1, 2, 3, 4, 5. So, from the 5th position, the hydrogen will be transferred to 1st position. So, how it will happen? Here one hydrogen will leave, this bond will shift here, and you know what I want to do here, right? Wait a minute. This is H, this is H, this I want to write here, this is the 5th one, okay? Now see what will happen. This H will transfer, this bond will shift here, conjugation will happen, this bond will shift here and this bond will shift here. It will have O negative where this hydrogen will get attached, okay? Now what will happen? You will have this, you have to do the conjugation, okay? So this system has shifted here, double bond here, right? Here its system is, this system has shifted here. This is OH, system I am saying, okay? This system has shifted here. This is a double bond, this is a OH. That means, can we say actually this is a keto form of phenol. This is PHENOL. This is also enol. Enol. So, phenol tautomerism is this structure, right? Can you see that? 12th date sheet is released, is it? Awesome, awesome, awesome. That's great, 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 great. Okay. Abhishek, don't worry, you will make it this year. Don't worry about that, right? So, never, we can see now, even with one failure, this system has not given up. So, be like 1,5 system. Don't be like 1,3 system who is only like one chance and it's gone. No, right? We can see two systems here, right? We can see two systems here. This system is not giving up. Be like this system. Don't be like this system, which is just, okay, I have failed, I'll give up. Don't be like this system. Okay? Don't be like this system. Right? Okay. Now, let's talk about more tautomerisms here. Let's talk about more. So, keto-enol tautomerism, will it show or not? Guys, let's talk about, will this show keto-enol tautomerism or not? Everybody here, if you see, this is the main CO bond, right? This is alpha and this is also alpha, right? This is alpha, this is also alpha. Now, both the alpha, if you can see, this is 1, this is 2, 3, 4, 5. This is 2, 3, 4, 5. So, third is sp2, here also third is sp2. Now, we'll go for 5th carbon. Now, 5th is also sp2. So, it has failed in 1,3 system also, 1,5 system also. So, 1,3 and 1,5 system, both are not possible in this case. So, it will not show any kind of tautomerism. So, we can say no tautomerism is possible in this case. Let's talk about this part here. Let's talk about this question here, everybody. So, what you have to do, you just have to write out 1, 2 and see this here 3, 4, 5. It can also be 4, 5. Okay? Yes, both things are possible. It can also go 1, 2, 3, 4, 5. Or even if you go 4, 5, that is same thing only. Now, in this case, third is sp2. 5th is also sp2. So, it is not possible in this case. Here, third is sp2. If you think that ma'am this is third is sp2, it will go like this, no, it will not actually choose this, because if you have to choose this particular fifth hydrogen, fifth carbon, then this will remove, this bond will shift here. It is happy only, it will be like this. Which tautomerism it is showing? No tautomerism, right? Okay, so how it will behave? This will be from this particular hydrogen, right? This will get removed, this will shift here, this will shift here further, this will shift here. This kind of tautomerism will be shown. 3 and 4 should have double bond. Third and fourth should have double bond, okay? Third and fourth carbon should have double bond between them, right? Okay, so we can say this is third, this is fourth, this is fifth, and here this is sp2, but this one is sp3 with alpha hydrogen. So this is going to show 1,5 system tautomerism. Okay, 1,5 system tautomerism it is going to show. And how it is going to show? This is hydrogen, this is hydrogen, this hydrogen will leave, this will jump here, this will jump here, this will jump here, and that's how a very beautiful tautomerism we can see over here, right? Beautiful tautomerism we can see over here. This will remain like, this will be benzene, right? Okay, this will convert it to OH. This will be double bond, this will be 1, and here this bond will shift here. This is going to be the tautomer here, right? This is going to be the tautomer here. Clear everyone, right? Right side ma'am, very good. 1,5 system ma'am, very good, right? 1,5 system is possible here. That is 1, 2, 3, 4, 5. I have also shown you how it will look after tautomerism, and this is the own part, and this is the enol part, okay, this is the enol part that we are talking about, right? Okay, so what is the system that you have to understand? First thing is, you will see whether the third carbon is sp3 or sp2. If the third carbon is sp3, then you will see whether it has alpha hydrogen or not. If there is alpha hydrogen, 1,3 system will be shown. If it is no alpha hydrogen, no tautomerism will be there. It is sp3. But if third carbon is sp2, then you will go for fifth carbon. If it is sp3, it has alpha hydrogen, then you will say it is 1,5 system. Okay, right? This is how you answer tautomerism, right? There are so many PYQs that we are going to discuss upon that. Before ending the tautomerism part and before jumping to the PYQs of tautomerism, let's understand this part here. Let's understand this part. This is nitro, Se nitro. So this particular part is nitro. Let's see how Se nitro it will be converted to. This will be 1, 2, and this is 3. Okay. So here what will happen, you will have CH3, you will have C, this is H, this is H, this is N, this is double bond O, this is O. So, should I write it 1, 2, 3 or 1, 2, 3, right? So whatever you write, either you write 1, 2, 3 or 1, 2, 3, you know that here double bond will be shifted from this to this side. So, break the double bond of 1 and 2, shift it to 2 and 3, shift it to 2 and 3, right? Then, to where you have shifted the double bond, from the third position, shift it to first position, right? That means hydrogen you have to shift here. And this is called Se nitro. Se nitro. Okay? So, this is a tautomerism of nitro and Se nitro. They can also ask you this, no? So that's why, just to be, sure that we don't do any mistakes here, right? Wait a minute, let me just delete some extra slides. Okay, yes. Now if you see, this one will be 1, 2, 3. Again same thing, this is CH3, this is C, this is N, this is double bond O, this is H, and this is H. So from 1 and 2 position, break the double bond, attach it to 2 and 3 and shift the hydrogen to first position. And that is going to be your nitroso-oxime tautomerism. Oxime tautomerism, and that is going to be the answer here. Right? Okay. Ma'am, SA nitro carbon 5 bonds you did. Where? Oops, I'm so sorry. I forgot to remove hydrogen from there. From third position, hydrogen will be shifted, transferred to the first position. Okay? Yes. Okay, everybody. Now, next is this one, that is amine and amine. So, here also what you will do, draw the same structure. C, this is H, this is H, this is CH, double bond NH. This is amine, and if you write the positions here, this is 1, 2 and 3. So what will happen here, double bond from the 1, 2 position will be removed, right? And this will be shifted here to 2 and 3 position, and H will be transferred to this position. And what is this? This is enamine. This is amine and this is ene. So this will be enamine. Like you have enol, similarly you have enamine, and here it is imine. Like you have ketone, double bond O, right? Similarly you have imine, right? Okay, everybody, do let me know if that is clear. This is the tautomerism here, right? Okay, everyone, right? Janani, Hashvita, Harish, Rama, Raju, Anuradha, do let me know in the chat box if there is any problem here, right? If there is any problem, do let me know in the chat box, right? So that we can start with some questions, some PYQs of JEE, right? Let's see how they ask you this. Let's see how they ask you this. Let's see how they ask you this. If you see this, guys, this is how many isomers can you draw for the following structures, right? So, sorry, isomers, they are saying how many tautomers you can draw, right? So, the number of alpha hydrogens is going to tell you the number of tautomers, okay? Not the number of tautomers, but yes, I'll tell you how. Wait a minute, not the number of alpha hydrogen, I'll tell you how. See, this is amine, this is alpha, right? That means if I say this alpha, then if I take it as 1, 2, 3, the possible tautomer is, this will become OH and this will become double bond, this one. And if I take 1, 2, 3, this as alpha, then what will happen? Then the bond, double bond will shift here, this will become OH. Isn't it? Okay. So these are the 2 tautomers that is possible here. These are the 2 tautomers that is possible here because you have 2 alpha carbons. The number of alpha carbons which are sp3 is going to tell you how many tautomers you will have. So that means 2 tautomers are possible, either this or this, right? So answer will be B is the correct answer here, right? 2 tautomers are possible in this case, not the number of alpha hydrogen, guys, because alpha hydrogen means even if you take out this hydrogen or you take out this hydrogen, it is going to form this only. But here if you take out this particular hydrogen, it is going to form this. So this particular hydrogen, when you take out, it will show this one thing. If you take out these 2 hydrogen, it will show you this tautomer, right? So 2 tautomers are possible here. Okay? When the alpha hydrogen, don't count it by mistake, I told you alpha hydrogen, alpha carbon, okay? Alpha carbon will tell you how many how many tautomers will be formed, because even if on one alpha carbon you have 3 alpha hydrogen, but those 3 alpha hydrogen will shift and they will give you the same tautomer only, right? Okay, understood? So answer will be 2 is the correct answer here. How many tautomers? That's the difference in hyperconjugation and tautomerism. That's why I told you they are not related to each other, right? How many tautomers can you draw from the following structure? This is double bond O. Now if you see, this is alpha, this is alpha. First tautomer that is possible here is, if I say, let's say this is alpha, so I'll draw it with the red pen. So this is alpha, so the tautomer possible is this. This will convert to OH. This will shift here, right? This is 1, 2, 3, na? It will shift here and this will become this kind of situation, right? Another possibility is 1, 2, 3, this is alpha. So in this case, you will have, this is OH and here this double bond will be formed and this is the tautomer that you will have. So two tautomers are possible, this one is possible and this one is possible, right? And this one is possible, right? So answer will be 2 is the correct answer here, right everyone? 2 is the correct answer here. Sanjana, when the class will end? It will take a time to end the class, beta. Isomerism in this much detail if I am teaching you now, it will take time, right? It will take time. Now we will start geometrical isomerism. I want you guys to at least cis and trans we should do, and if you want E and Z also I'll complete. I want to complete today, but if you're like, ma'am, let's do till cis and trans, we'll do that only, right? Okay, now tell me everyone, is that clear? B is the correct answer, yes. Now let's talk about this one. Which of the following is a tautomer of phenol? Which of the following, ma'am, is it always 2? Maximum it can be 2, to be very frank, maximum it can be true, but don't use tricks here, okay? So what I told you, draw it, right? Maximum it will be 2 only, because for the ketone part, more than 2 carbon is not possible, right? But for that you also have to see if here you have a double bond, then you will have only one possibility. If here also you already have a double bond here, then also, no. If here you have a double bond, this is 1, 2, 3, 4 and 5. Then 1,5 system is possible here. Here 1,5 system will be possible, but here there will be no possibility. So that's what I am telling you, don't cram this that always it is going to be 2. It depends na whether 1,5 system is available or not. If 1,5 system is also failing, if 1,3 system is applying or not. Right, so you have to, like, basic knowledge you should have about it, right? You can't just cram it, but maximum it will be 2 only, or it will be 1, okay, or it will be 0. 0, 1 or 2 will be the answer, right? So, which of the following is a tautomer of phenol? Yes, everyone, if I draw it, A, B, C, D, we have drawn it. It is by 1,5 system. It is by 1,5 system we make phenol. First thing is, when you want to talk about tautomer of phenol, that will be a keto. Keto means there will be a double bond. Enol means there will be a double bond O. So this double bond OH is already eliminated. This is only single bond O. This is not even a correct thing. This is OH also and this is double bond O also. This is also eliminated. So you don't even need to know that. Already if you have a basic knowledge, you know that enol will form a ketone. So there should be a ketone. Ketone is only present here. And if you draw it, if you want to draw the phenol form here, right, this will be 1, 2, 3 and this is going to be the tautomer. Yes, it is a tautomer, right? So how? Because this is hydrogen, right? So what you will do, this double bond is shifted here, hydrogen will be shifted here. Isn't it phenol? Yes. So that's how you will see that C is the correct answer here. Very good, Surya, Anuradha, Ramaraju, Abhishek. Very good, very good. Yes. So let's talk about which of the following structures can show tautomerism. Ma'am, is it important for board examinations? Yes, absolutely right, Abhishek. That depends upon which board, but for board examination, this much detail, see, some parts you should definitely know. But as far as it is important for competitive exam, it is not that important for board exam, but definitely it is important, right? But in competitive, it is one of the most important topics, right? Okay, you can't afford to skip it in competitive exams, especially in JEE, you can't afford. You yourself can see, I am showing you PYQs only and you can see that on tautomerism only so many questions. This is what I told you in the starting, that tautomerism you will see a lot, right? Because others were simple only. Position, function was quite simple. This is something that level is good, so they can ask you, right? Which of the following structure can show tautomerism? Now you have to define which structure will show you tautomerism. Yes, students, which structure is going to show you tautomerism? Yes, everybody. Right? Okay. Yes, these are some here PYQs only. Which of the following structure can show you tautomerism? If you see this here, this is alpha, right? This is sp2, this is 1, 2, 3, 4, 5. Fifth carbon is also sp2, so it will not show. Here it is, this is alpha, here for this one, this is alpha which is sp3 which has alpha hydrogen. Here also this is alpha which is sp3 which has alpha hydrogen. So this is possible, right? Here this is alpha, if you see 1, 2, 3, 4, 5. This is also sp2, fifth is also sp2. Similarly in this case also it is 1, 2, 3, 4, 5. Third and fifth is sp2. So definitely it will not show any tautomerism. So answer will be B is the correct answer here, right? Okay. Yes, everybody. Next is which of the following exhibit tautomerism? Here also you need to tell which of the following will exhibit tautomerism. Yes, everybody, do let me know in the chat box if you can answer this or not. Here, this is alpha, this is also alpha, but this is sp2. So here 1, 2, 3, 4 and fifth. Fifth system is also sp3, but this is no alpha hydrogen. So from this side, no possibility. This side, there is no possibility of tautomerism. From this side, there is possibility of tautomerism because this is alpha, which is sp3, which has alpha hydrogen also. From this side, it can show tautomerism, right? So this will show tautomerism from this side. From this side, it will not show. From this side, it will show by 1, 3 system. Okay? Here also, this is alpha, this is again alpha, this is 1, 2, 3, 4, 5. If your third carbon is sp2, fifth is sp3 with alpha hydrogen, so it will show by 1, 5 system. It will show this, it will show tautomerism by 1, 5 system. 1, 5 system. Here it will show by 1, 3 system. So definitely it is showing you two kind of tautomerism. From two parts it is showing you two tautomers will be formed here. Here it will be two tautomers. Here it will be one tautomer. Okay? That is how you should know, right? Then this one. This one is alpha. This is sp2. So this is also fifth carbon, which is sp3, which has alpha hydrogen also. So it will show you tautomerism from this side. From this side, this is alpha, this is sp3, but no alpha hydrogen is there. No alpha hydrogen is there, everybody. No alpha hydrogen is there. So from this side, it will not show any tautomerism. So only one tautomer is possible. And that too 1, 5 system. Here both 1, 3 and 1, 5. Here it will be 1, 3 system. Tell me guys if that is clear to all of you. All are showing you tautomerism. Here it is 1, here it is 2, here it is 1. Right? Okay. So all of them are showing you tautomerism. Okay. Yes, everybody. Do let me know if you have any problem in tautomerism, so that we can initiate our stereoisomers, right? Efforts, very nice lectures, able to understand everything from basics. Thank you so much, Lokesh. Thank you so much. That means a lot. These are the things that we live for, isn't it? These are the things that we generally live for. Thank you so much, right? Okay, so just give me a minute. I'll just take rest for 1 minute. Acha, now everybody spam it, green hearts in the chat box, right? so that we can start with stereoisomers, right? Today I'll try to do, let's do cis and trans, because EZ I think today is not possible. So we'll do EZ in the next class, right? But let's do cis and trans today, okay? Let's do at least cis and trans today. I think that we can do, right? That we'll be able to do by today. Okay, everyone. Very good, very good. Chemical that is on my mind about chemical thermodynamics and equilibrium. I know that we are left with that, but what I want to do is firstly let's complete organic chemistry. Don't worry, I'll take side by side thermodynamics and equilibrium also. I don't want to break this flow, right? Organic chemistry goes with a flow. If I break it in between, you know, that will go, right? The interest will also go, right? So let's finish this off firstly. Those are very simple small chapters, don't worry about that, right? So let's talk about stereoisomers. Stereoisomers means the spatial arrangement has to be different here. The arrangement in the space is different. So there are two kind of major distribution of stereoisomers. That is, first is configurational and then there is conformational. In conformational, in hydrocarbons you have a topic. The topic is conformers of alkane. Conformers of alkane. And these conformers of alkane, we are going to do that, right, in the third lecture of isomerism. That means next, that means on Friday I'll do conformers of alkane, right? Simple topic it is, but very interesting in 3D oriented topic it is. So we'll understand in that. Hydrocarbons separately, I will not teach you isomerism because right now we are doing isomerism. So here only I'll teach conformers of alkane, right? That is in your syllabus, right? Then configurational isomers, right? That is divided into two parts, that is geometrical and optical isomerism, right? Okay, and today we are not talking about optical isomerism, we are not talking about conformational isomerism, we are only talking about geometrical isomerism. So let's understand what exactly is geometrical isomerism, because the questions like this are asked, which of the following will show geometrical isomerism? So you have to know the conditions, and it's very simple, trust me, it's very simple, even the calculations is simple, right? So firstly, for geometrical isomerism, right, it is not possible in case of alkenes. Why? Because for geometrical isomerism, you need restricted rotation, right? The rotation has to be restricted. Now, I'll do one thing. Shall I make a compound for you to show you that how restricted rotation looks like, okay? Do I need to do that? Yes, everybody. Do you want me to make a compound where you can judge that how restricted rotation looks like? Okay, so let's do that. Let's do that. 1, 2, 3. Array. 1, 2, 3, 4. Yes. Okay. So here, let's make a double bond. Okay, let's make a double bond here. This is a single bond. Here I am making a double bond. I am connecting this double bond here and I am making a double bond here. This is a double bond, okay. Now let's see, you have this thing here, right? So I'll explain you this with 3D only so that you can actually understand what is happening here. See, if I take more time, that means I'm going to show you something so that, you know, you remember it like for more time, right? Now this is alkene in which we are going to see the rotation. Now first thing I am saying that the geometrical isomerism are shown when restricted rotation is there. Can you see this double bond? If I have, I am not able to rotate it. Am I able to rotate it? No, I'll have to break the bond to rotate it, right? And it's not possible for me to rotate it. So this is restricted rotation. If you talk about alkane, right? In alkane there will be full rotations, right? Like this, full rotations with a single bond. So that's why here restricted rotation you have. So that's why we are discussing it in the alkene part, right? So that's why in alkene. Now the question is, ma'am, why we are not discussing it in alkyne? Ma'am, in alkyne, ma'am, you have 3 triple bonds. You have 3 bonds. That means you have triple bonds. Ma'am, triple bonds also has restricted rotation. Then why we don't discuss geometrical isomers of alkynes, right? That can be a question, that why do we don't discuss geometrical isomerism of alkynes? See, another condition for existence of geometrical isomerism is that if this is a geometrical isomerism, this we can only define if on the same carbon you have two different groups, okay? It's like this. On the same carbon you should have different groups. It doesn't matter if on two different carbon, if these two are same, doesn't matter. These two on the same carbon has to be different. These two has to be different. Only then it will show geometrical isomerism. Otherwise, it is not going to show any geometrical isomerism. Keep that in your mind. It is not going to show any geometrical isomerism. If a carbon here, these two groups, if they are not same, right, then it is going to show geometrical isomerism. If they become same, it is not going to show. Is that clear to everybody? Two things that we have. Now the question is, ma'am, in triple bond, ma'am, let's say we have triple bond, okay? In triple bond, you have on one carbon, you have only one atom. So there is no thing of same on one carbon you have same or different. On one carbon you have only one atom. So which you are going to compare it with? So that is why in alkyne also we don't discuss geometrical isomerism. That is the reason we discuss geometrical isomerism only in case of alkenes. Okay, alkenes, right? Okay. Ma'am, could you show your collection of toys? This is how it looks like, right? Very mismanaged, right? So this is how it looks like, and I just keep rearranging themselves, right? So and you know, that's how we play with these toys, right? Okay, now let's understand that. Let's firstly understand. Ma'am, start organic chemistry for 12th. That will start in next class, on the next week, because isomerism of 11th we are done. Purification, qualitative, quantitative is a very simple chapter. One shot I'll do for that, right? In detail, I am not going to do purification, qualitative, quantitative. That is for one shot. I'll take some 4 or 5 hours lecture someday and I'll complete that, right? But detailed lectures I want to take for hydrocarbons, haloalkanes, halorines, because they form the base. And one shot of that is not possible. It will take me around 7, 8 or maybe 10 hours to complete it in one shot. The kind of detailed lectures that I give you, right? Okay. So now understood one thing. Geometrical isomerism we are going to discuss in case of alkene, and in this case on one carbon, right? What should be clear with? This first group should not be equals to second, and this third group should not be equals to fourth. Only then geometrical isomerism is possible. That means different groups on same side of double bond, right? That is the condition, right? Now let's discuss whether the geometrical isomerism will exist for all of them or not. So A is geometrical isomerism here will exist or not. On the same carbon you have same methyl group. That means geometrical isomerism will not exist here. You need to have different alkyl, you need to have different groups here, right? Here you have same, so here also geometrical isomerism will not exist, right? Okay, then yes, it will not exist. Then is this one. Now this is very simple to say, whether you just have to see and look, okay, these are same, not exist, these are same, not exist. That's why they hardly will ask you these kind of questions, right? What my idea is, they should ask you these kind of questions where, you know, little bit brain you have to use. Now, in this case, we know that methyl and hydrogen is different. Here, methyl and hydrogen is different, okay? Let's understand this part, ma'am. How do you define in a ring whether it's same or not? In this case, we'll see the environment. One by one, what is the trick here? One step at a time. One step at a time. One time you will take one step and then you will see whether it's same or it's different. Let's talk about that, right? Let's talk about that. So one step at a time means here if you go to this side, you will have CH2. You go to this side, you will have CH2. You'll go to this side, you will have CH2. You go to this side, you will have CH2. Can I see any difference here? Here also the environment is same, here also the environment is same. That means this will not show GI because the environment on both sides is same, right? Okay? Yes, GI does not exist. Now let's talk about this one. Here, usually how I explain my students, let's see, right? You go to this side, it's like you want to, there are two ways of going to your friend's house, right? So this is the way if you choose. Here you have, you met Bromo, that means you met Bintu. You met Bintu here. You're like, hi Bintu, how? Two ways, like always there is two or more ways in India to go somewhere, right? So let's say you want to go to your friend's place. So there are two ways you can go to your friend's place. In first way, if you go, you will meet Bintu. You will say, hi Bintu. And in the second way, you will meet Chintu. You will meet Chintu. Now tell me, how can both the ways same? Here you are meeting Bintu. Here you are meeting Chintu. That means the environment is different here. The atoms that you are meeting is different. Here this is CH2, this is also CH2, but in CH2, in CH you have the placement of Cl. Here in CH you have the placement of Br. That means the environment is different, that means it is going to show GI. Tell me, is that clear? Is that clear everybody? How you are going to see whether it will show GI or not? How you are going to see whether it will show you GI or not? Is that clear to everyone? Yes, everybody. Is that clear? B will exist. Absolutely right. Harini, Surya, Umakant. Very good. Abhishek. Awesome, awesome, awesome. So let's see. Okay, next one, next one. Very interesting. This is very interesting. No GI, show GI. We know that. Yes. Now let's talk about this. A and B. Let's see. It's very interesting. You're going to have fun, right? You will enjoy it. You will enjoy doing these questions, right? Let's see if it shows GI or not, right? Let's see that. Let's see that. Okay, everybody? Yes, everyone? Let's talk about this. Methyl is same. We don't even need to see this. Here definitely it will not show GI. Sometimes students go and look into difficult part. They are like, ma'am, here environment is different, ma'am. Here it is, ma'am, CH2, ma'am. Here it is, ma'am, CHBr, ma'am. Environment is different, ma'am. It will show GI. What about this methyl? You have not seen that. Methyl, GI is not possible here. In this case, that's why I always see. That's why I'm always looking at the easier part first. These are different. Here we are sorted. Here condition is applied. What about this one? Here you go. This is CH2. This is CH2. Here you're meeting CH2. Next step is here you're meeting CHBr. Here you're meeting CH2. So that means environment is different, right? Environment different means GI is going to exist here, right? A doesn't exist, B will exist, right? A will show geometrical isomerism. No, A will not show geometrical isomerism, right? Okay. Let's see this one. Let's see this one. This one is very important, okay? This one is quite important. So please, like, carefully you have to see. Carefully you have to see this. Okay, let's firstly talk about this one. Chlorine, bromine are different. Okay, condition followed. Here it is CH2, CH2. Here it is CH methyl, here it is only CH2. That means environment is different. Environment different means it is going to show GI. That means it is going to show GI, right? Environment different means it is going to show GI. Now, interesting part is this one. This one is interesting. Why? Because of so many reasons it is interesting, right? Let's talk about that. Here, this is Me, this is H, this is different. So, we have sorted that this condition is followed, right? On same carbon, you have different groups. Now, let's talk about this part here. Tell me, in A, will it exist or not? Let me see what you can guess here. In A, will it exist or it will not exist? Yes or no? Will it exist or it will not exist? Let us see that in the chat box. Let us see that in the chat box, right? I'll see, I know, I can understand. Mixed reactions I know I'll get, right? Because till now I have not told you about that part. I guess it won't exist. Okay, some Abhishek is saying, ma'am, it will not exist. Ramaraju is saying it will exist. So mixed reactions you have on that. Let's see, okay? Let's see. I'm so happy that you guys are trying. I'm so happy on that, right? Because you know, this will make your mind remember things when you are doing the questions that, okay, ma'am asked me, then I answered it, I guessed it incorrectly, but then I got to know that why I answered it incorrectly, right? So if you see here it is CH2, here it is CH2, it is same environment. But on the next part, this is also carbon, this is also carbon. On the same point they are at. It means I am standing on a point where here Bintu is standing, here Chintu is standing. I am like, hi Bintu, hi Chintu, how are you? Like this I am doing, right? In previous things we were doing, I was following a different path, I met Bintu, on a different path I met Chintu. Here, after crossing it, I am on the same point, I am like, hi Bintu, hi Chintu, on the same point. That means the environment is same only, right? So that means the environment will be same at same point I am standing where I am saying hi to Bintu and Chintu, right? So chlorine and bromine are at the same carbon, that means environment is same. So GI will not exist here, right? GI will not exist here, right? Everybody got it? Understood why it is not existing here? Because the environment is same here, right everyone? Okay. Yes, mistakes. So one of the students I met, like he was in he was a rank holder, AIR 5 he was, right? 2021 AIR, yes, AIR 5 or 6, I think 2020 or 21 he was, right? And but I met him in not in IIT event, I went to AIMS, right? So it is also like a very prestigious institute, right? So JEE aspirants can also get an inspiration from there. So I met him and I asked him like, what is the advice that you will give to your juniors? And one advice he gave, and I still remember it and I'll quote it. He said, I would advise the students, my juniors, that they should make mistakes. If they are making mistakes before the exam, that is so much better than doing mistakes in the exam. And if you are not making mistakes before the exam, most probably you are going to make mistakes in the exam. If you are not making mistake before the exam, that means you are not learning anything new, right? If you learn something new, or you have to be genius, right? Who is not making any mistake in any question. If you are making mistakes, just learn from them. Because that's the thing that, okay, today I am making mistake, but that I am sure that this same mistake I am not going to do in my exam. Right? Okay? Yes. Chalo. Right? Now, no GI and this shows GI. Now, let's talk about this one. Will GI exist here or not? Let's talk about this one. Will GI exist here or not? Right? So, here it is. If you see this is double bond. Here it is showing CH double bond, here it is showing CH2, so environment is different. Here it is showing CH double bond, here it is showing CH2. So that means environment is different, GI will exist. Sometimes we just look at it, okay, this is symmetrical, this will not show GI. No, you have to see on this carbon whether the environment is same or different. Okay, that you have to see. Here, this is carbon, this is CH2, this is also CH2. Here also you are meeting CH2, here also you are meeting CH2. That means the environment is same. Here also, up and down, here also, environment is same. So, GI will not exist here. Right? Okay, B will not have any GI in B. Yes, A will have GI. Very good, very good. Mistakes are proof that you are trying and still failing. Yes. Right? And when you are failing, that's a reason that will lead you to your success. Don't worry about that. Right? That will lead you to a successful journey that you deserve. Right? Now guys, let's talk about cis and trans. Okay? So firstly, you will have to see, don't just answer this is cis and trans. First, you will have to see whether it is showing GI or not. Now tell me one thing, will this show GI? Some students, they directly say, ma'am, yes, this will show GI. Tell me, can you see, wait a minute. Is this cis or trans? Some students, they are like, ma'am, white, ma'am, they are on the same position, same side, ma'am, this is cis. Some will say, ma'am, white, ma'am, they are on the opposite side, ma'am, they are trans. How can you say this is not showing cis and trans? Why? Because same carbon have two same groups. So it is not GI only. If it is not GI, then what's the point of cis and trans? First, you have to check whether it is showing GI or not. If it is showing GI, only then it can be cis and trans. Right? Now, this is GI. Okay, now this is GI. Okay, on same carbon you have two different groups. On same carbon you have two different groups, right? Now this means it shows GI. That means it will show cis and trans. So if cis means both on same side, now I am not saying same carbon, understand? GI I am saying on the same carbon they should be different. On the same carbon they should be different. Cis and trans I am saying on the same side. This is the same side. This is the opposite side. Okay. So when on the same side, right, you have yellow, that means yellow atoms, that means same. This is cis. On the same side you have white atoms, this is cis. So how do you remember? Sisters are always together. Sisters are always together. Sisters are always next to each other, doing gossips and all, right? So sisters are always together, right? Cis sisters, that's how you can remember this, right? Now, if I see that this is opposite, right, that will be trans. Trans means opposite. So these two atoms are opposite, which are same atoms are opposite, same atoms are opposite, that means it is trans. Okay, that's how you define cis and trans. Okay, everyone? That's how you define cis and trans. So this is going to be cis, right? Same side. This is going to be on opposite side. So this is going to be trans. Right? What about this one? Firstly, tell me, is this cis or trans? Let me see. Is this cis or trans? Is this cis or is this trans, everybody? Yes. No, GI only. Very good, ma'am. What are you talking about cis and trans? Same carbon, two same things, ma'am. It is not even a GI, ma'am. Forget about cis and trans. So, no cis, no trans. Okay? No cis, no trans. Right, everyone? No cis, no trans will be there. Right? Okay, what about this one? Which is cis, which is trans? This is A, this is B. Tell me which is cis, which is trans? Neither cis or not trans. Very good, very good. What about this one? Which will be cis, which will be trans? Which will be cis, and which will be trans? Which will be cis here, which will be trans here? Everybody, let me know in the chat box which will be cis, which will be trans. Chlorine, chlorine on the same side, this is going to be cis. CH3, CH3 on the opposite side, this is going to be trans, right? So that's how you can define cis and trans here, right? Okay. First you have to check whether this is GI. This is GI, this is GI, this is GI. So that's how I can define cis and trans after that. Right everyone? Okay. Now let's talk about cycloalkane. In cycloalkane, how will you show? So first thing is, just like in alkene, see the formula is also same of alkene and cycloalkane. Similarly, they both have restricted rotation also, right? In cycloalkane, you will have restricted rotation because of a cyclic structure. And because of that restricted rotation, they are going to show GI. Okay, because of that restricted rotation, they are going to show GI. Right? Now, there are 2-3 ways of understanding it. First way is, I'll just show you how to understand that. First way is to understand it with the help of a trick. The trick is same substituent on different position. That means you should not have same substituent on same position. If you have same substituent on same position, it will not show GI. Same substituent, same position, no GI. No GI is possible, right? So if you have same substituent on different position, it will show GI. This is a trick, okay? Same substituent on different position, it will show GI. Right? If you see this here, wait a minute, I'll just keep it here. Different substituent on different position, it will also show GI. This will show GI, right? Then you have, will this show GI? No, because here same substituent on same position, so no GI will be there. This is a trick to answer cycloalkanes. Now, actually I don't have that. I can make it, I'll make it, you know, but it will take me time around 10-15 minutes to make it only, right? Right, I'll see if I can see something, right, on some, like, you know, platform, right? If I can see something which I can show you on 3D as well, cyclic also, I'll see that, right? But now guys, let us see this, that why it is shown, why I'm telling you that this is a trick, why this trick is there, right? Let's understand. So this trick simply means that, I'll just show you what do you mean by this particular trick, okay? What do you mean by this particular trick? What does it mean? Okay? So this trick simply means that here, this whole part, you make a double bond of it. So this is a double bond. This is CH3, this is CH3, this is H and this is H. Can you see on the same carbon you have different, on the same carbon you have different. Okay, and I'll also tell you about others also. Let's see, I want to talk about this one. Let's see, I want to talk about this one, right? If I make all of this a double bond, right? This will be double bond, this is Cl, this is H. Because of restricted rotation, we understand it that way, right? This is methyl and methyl. Now, can you see on the same carbon, you have two methyl group. That means that's why it is not a GI. You just convert it into it, right? So that this becomes easy for you to understand. If you talk about this one, this whole part is converted to double bond. So this will be C double bond C, this is Cl, H, this is HBr. So on same carbon you have different, on same carbon you have different. So that's why it is a GI here. Understood? Yes, everybody, do let me know if that is clear to all of you or not. Right? Do let me know, guys, if that is clear to all of you or now not. Okay. Number of stereo isomers we'll talk about later, right, in the next class. This is based on geometrical only, so this we can discuss. Okay, this PYQ we can discuss. There are some previous year questions which are based on cis and trans that I'll discuss today. List E and Z configuration and anti-sin will discuss in the next class. Calculation of number of geometrical isomerism will discuss in the next class. Along with, we will start with RS, optical isomers we will start with, right? So that we'll do in the next class, right? Now let's see this. The incorrect statement regarding geometrical isomerism is propene shows geometrical isomerism. So if you see, this is propene, this is CH3, this is H2 and this is H. If you see this here, this will be H and H. Can you see on the double bond on one side you have same atom? So obviously it is not going to show any GI. So this is the incorrect statement, right? This is the incorrect statement. Next is trans isomer has identical groups. On the opposite side, that is true, right? This one is false, this one is false. Cis-but-2-ene, that means this thing. But-2-ene means this. Cis-2-but-2-ene means this kind of structure. Has higher dipole moment than trans. See, if you talk about trans, in case of trans, guys, cis always has more dipole moment as compared to trans. Why? Because in cis the dipole moment is added. Here the dipole moment will cancel each other, right? So always cis has more dipole moment as compared to trans. Always cis will have more dipole moment as compared to trans. So this is also true. 2-methyl-butene shows 2-geometrical isomerism. Trans has, this I'll talk about, but let's see. Trans has lower melting point. Is it correct? No. Trans has higher melting point. Can you tell me why? Because the repulsions are less. Repulsions are less in trans. Whenever you talk about a trans isomer, in that case the repulsions are less. So that means the symmetry will be more in case of trans, right? You know, if you talk about this thing, I'll just show you that, these 2 points here. If you talk about trans, right, this is very important, okay? If you talk about trans, it will go like this. So, like you have chair attachment, like you have one chair, then on that you have one more chair, on one more chair, one more chair, one more chair, right? Similarly, you have trans. But in case of cis, that symmetry is not possible because of the same size you can't have that kind of symmetry, right? That symmetrical arrangement is not possible in case of cis. Because cis is of same, right? We cannot overlap it on each other. If you have same size of cis, you can't overlap. But a trans, see, if you have same identical chairs, 10 identical chairs you have, you can place one, then again one, then on that one, you can place it on one single row. Not even row, one single line you can place it, one single height you can place it. Similarly, you have trans which you can place like that. Because of symmetry, it has more melting point. But cis does not have symmetrical arrangement with each other, so it has less melting point. Cis has less melting point. So you will see trans always have more melting point as compared to cis. Okay, cis has more dipole moment, trans has more melting point. Now 2-methyl-but-2-ene. 2-methyl-but-2-ene, that is, but means firstly this one, but means but-2-ene, 2-methyl it means this will be this one. Now tell me one thing, is it showing any geometrical isomerism? Is it showing? No. They are showing 2 geometrical isomerism. No, not possible. So this is also false. This is also false. So first D and E. A, D, E are incorrect statements here, right? A, D, E and E are 6. See here, because of CH3 same, no GI is possible. Okay? Understood? Yes, everybody? Okay, now let's do one more question based on the same thing, that is cis and trans. Here it is showing, here they are saying JEE 2024, and this question, if you see, this was also JEE 2025 question based on cis and trans properties. Okay. Now, next is the incorrect statement regarding the geometrical isomers of 2-butene is. Incorrect statement regarding this. So, incorrect statement, let's talk about that. First is cis-butene and trans-butene are not interconvertible at room temperature. Yes, that is true. Trans-2-butene is more stable than cis-2-butene. Stability of trans is more, okay. In trans, repulsions are less, so that's why stability is more, right? That is correct. That is also correct. See, in trans, opposite, na? They are opposite. In trans, they are opposite, so repulsions will be less. In case of cis, they will be on the same side. So that's why they will show repulsions. This atom and this atom, here the atom is very small, but in reality, atom is placed here. Group is placed here fully. So they will show repulsions with each other, right? Cis-2-butene has less dipole moment than trans. No, cis has higher dipole moment. I told you that cis has higher dipole moment. So this is the incorrect statement. This is the false statement that you have. Here it is, cis-2-butene and trans are stereoisomers. Yes, they are geometrical isomers. Some students mark it wrong. Ma'am, no ma'am, they are geometrical. Geometrical isomers are also a category of stereo only. That's why they are a stereoisomers, right? So this is also correct. So this is the incorrect statement. So that's why this will be the correct. So this is true. This is also true. This is also true. Okay. This one is false. The third C part is false. So that's why C will be the correct answer here. Right? Okay. Yes, everybody. Let's talk about JEE 2024 question, that is based on again cis and trans. See, same question they are repeating, cis and trans properties, right? You can see for yourself now. Cis form of alkene is found to be more polar than trans form. If you see cis form, like you have this thing, polarity is more, that means dipole moment is more. Tell me one thing. Dipole moment of cis is more, isn't it? Yes, that is true. Dipole moment of cis is more as compared to trans, right? Dipole moment of trans isomer is 0. Yes, why? It will be cancelled. If here you have CH, here you have H, here you have CHE. So it will cancel each other, right? This will also cancel each other, right? So it will have 0 dipole moment. This is also true, right? So we can say both A and R are true and R is the correct explanation of A. So C is the correct answer here. Is that clear, everybody? Is that clear? Okay. Now let's talk about, okay, before this I want to write something here regarding cis and trans. If you compare cis and trans, let's talk about dipole moment. Okay, let's talk about dipole moment. Yes, everybody, let me know in the chat box which has more dipole moment. Then let's talk about melting point. This should be on your tips, okay? Then let's talk about melting point. Then let's talk about stability. Stability, okay? Cis has more dipole moment than trans. Melting point of obviously trans is more as because of the symmetry as compared to cis, and stability of trans is more because of the symmetry. It is having more stability, less repulsions are there. trans is more stable as compared to cis, right? Okay, everybody, thank you so much. Kanchra, thank you so much. Thank you so much. I'm so sorry if I am pronouncing your names incorrectly. I'm so sorry about it, right? Thank you so much for your love. Thank you. Okay, yes. Melting point of trans, and this is what you have to remember, right? Okay, everyone. Now let's see this question. Compound with molecular formula JEE 2021 question. See, very simple question they have asked here. Compound with molecular formula C3H6O can show position isomer, position and metamerism both. You have to, write it. If you write CH3, CH2, that will become 5 and this is OH. Isn't it C6H6O? Yes. So firstly, I am just trying to make functional isomerism here. Is it possible to make CH3O, CH3? Yes. So they can make definitely functional isomerism. But this cannot make metamer because alkyl chain you cannot separate. If you separate it ethyl here, then this will become H here. So metamer is not possible in this case. So metamerism is not possible. Functional item, this is not possible. Position of is also not possible. If you have CH2, OH, this is also same thing, and if you have OH here, this is also the same thing, right? So position is also not possible. So only possibility is functional isomerism. So answer is D is the correct answer here. Okay? Yes, everybody? Got it? How much questions should I solve? There is as such, I won't say solve 300 questions, right? You have to solve different type of questions. You should know how to solve different type of questions. If you are solving basic same category questions again and again, that is not going to make it to anything, right? Even if you solve 300 to 400 questions of same category, what advantage is that? You are just boosting your ego in that. You are just boosting your ego that I know everything because I am able to solve the questions. But in reality, you have not explored different types of questions. So if you ask me, ma'am, how many? I would say 2 to 3 questions of each category. Each category means like how in isomerism different types of questions they can ask you. They can ask you these theory based questions. They can ask you whether it will show GI or not. Those kind of things you should know, right? That is important, right? Okay. Yes, everybody. So I think that's it. Now let's see. Okay, this is also which of the following will show maximum enol content. Now this is a very important question. This I will consider it as an important and a good question that was asked in 2019, and I can also expect, right? Ma'am, 3 carbons, where 3 carbons? 3 carbons, 3 carbons, where 3 carbons? Yes, okay, 3 carbons, okay. I'm sorry. Let's see this CH3, CH2, CH2, 3, 4, 5, 6, 7, 8. Wait a minute. Oh, now the question will change only. Now the question will change in itself, right? Three carbons. Wait a minute. The question has changed. Yes. Right. So alcohol and that is not possible. I'm so sorry. Yes, it is 3 carbons. So it is 1, 2, 3. Alcohol is not possible here. But what is possible? Ketone and aldehyde is possible here. This thing is possible. Right. This thing is possible. CH2, C double bond O, H. By this thing they will show functional isomerism. Okay, chalo, we have done 2 questions then, right? If you have like say C2H6O, it can show alcohol and ether. But if you have C3, now you have to see whether what kind of Isomerism, it is showing by hit and trial method, and it is showing you functional isomerism. Again, here also meta is not possible because the chain we cannot differentiate here. Position is not possible because if you change the position, the functional group will change, right? So answer will be functional isomerism is the correct answer. Okay? Yes, everybody? Yes. Okay, now let's see this question, which is a very, very important question, right? And I can expect that if they ask you like this in repeated, like in the same question is repeated again, we can expect that. Easily we can expect that, right? Okay, so see, which of the following compounds will show maximum enol content is what we are looking for. Maximum enol content. Now to show maximum enol content, what we need to see? Right? In this case, if you see, this is CH3, this is C double bond O. Your alpha hydrogen should leave easily. That means alpha hydrogen has to be acidic in nature. More is the acidity of alpha hydrogen, more easy it will be to leave it. So if you talk about one by one, firstly A is not shown here, so I'll just show you A part here. CH3, C double bond O, CH3, this is a simple thing, Tautomerism it will show, but there is no additional groups that you have attached. So we can't say it is extra acidic here, right? So we can say it is okay, it is acidic. Let's talk about B. In B case, this is the alpha, this is also alpha, this is also alpha, this is also alpha. This alpha and this alpha hydrogen is same as what we have done here, right? This alpha is same as these two alpha, but this particular alpha is different, right? In this alpha carbon, here what is happening, it is attached to two carbonyl groups. Because of the attachment of two carbonyl group which are electron withdrawing, this makes it, okay? So CH2 group is between two electron withdrawing carbonyl groups, so hydrogen on this alpha carbon will be very highly acidic in nature. That is the reason this is more acidic. So first thing is that is this is already out of the race. Now we have to see C and D here. C and D. In C what you have? In C what you have? Okay, this is, so I just told you about, okay, hyperconjugation effect, that we'll do later on. Let's see C part here. In C what you have? CH3, C double bond O, CH2, C double bond O, OC2H5. Instead of CH3 here, that is in the B part, you have OCH2H5 here. Because of this OC2H5, can you see if here you have tautomerized product, if here instead of C double bond O, here it used to be like C double bond O CH2. If instead of that, here you have, wait a minute, it should be one hydrogen here, right? It should be one hydrogen here, right? If here you have, this double bond has shifted here, this hydrogen has shifted here, and here you have OH and here you have double bond O. In this case, what you will observe that here, because of this OC2H5, these electrons will jump here, this will jump here. This will be O negative, right? Here you will have O negative. So what will have? Between this and this you have cross conjugation that is going to take place here. Another conjugation that can happen is this bond shifts here, this bond shifts here. Isn't it? In this case, can you see any cross conjugation here? If here enol part is formed, yes, hydrogen bond is here also. See, simple thing is, hydrogen bond is not the differentiating factor. You can see hydrogen bond here also. You can see hydrogen bond here also. You will see hydrogen bond in the D part also. So that will not define, right? Definition, the differentiating factor is, here you have only one conjugation, that will be if you have here this. Here this double bond will shift here, this double bond will shift here, that's the only conjugation, that is extended conjugation, right? Here you have cross conjugation. When you have NH2 instead of CH3, here also you will see one part is this one. Other conjugation part is this double bond shift here, this double bond will shift here. Again you have cross conjugation here. And always we know that extended conjugation is more stable as compared to cross conjugation that we have studied in GOC. right? So can you see how smartly they have connected GOC with this Tautomerism, right? So this I would say is a very interesting question. It can be repeated in molded form. So mark it important. So in this case, that's why because of cross conjugation, this is eliminated, this is eliminated. B is going to be the correct answer here. Is that clear, everybody? Okay, I'll call you Shrishant. Okay, yes. Yes, organic chemistry is so hard. Yes, that's what it is, right? That's what make it more interesting, isn't it? So guys, that's it for today, and this we have done. Now you have a question for your homework, right? So write it down, JEE 2025 question. That is, you have to identify the correct statements out of this. You have to tell which is the correct statement out of this. These are the options that you have. Correct statement out of this. Take a screenshot of this one, everyone. And please start doing your homework. When you will do your homework? So many times I am waiting for you to do your homework, but you guys are like stubborn. Ma'am, we will not do homework, ma'am. You do whatever you want to do, right? Start doing your homework. It is important for you to do, because if you don't do your homework, right, then the match will not be there, right? Because in the next class, I'm going to teach you EZ configuration, EZ geometrical isomerism. For that, we'll learn about CIP rule, Carl, Ingold and Prelog, right? CIP rule we'll talk about. Then we'll talk about RS configuration, DL configuration, geometrical isomerism, how to calculate number of geometrical isomerism, how to calculate number of stereo isomerism. So all these things you can only understand if there is a flow that you have, right? So that's why I try to keep the lectures like today, next day and next day, right? So that I can finish off the topic like that. So today I'm going to complete isomerism in next 2 days. Today we have done the first part, tomorrow and the next day. That means by Friday your isomerism will be over. On Saturday, I'll take a special session for you, right, where I'm only going to discuss about the questions of GOC, right? Okay? Understood, everybody? Yes? Okay, students, shall I now write? Okay. Okay. So, take a screenshot of this one also. Yes, everyone. Which will be the correct answer, right? And that's it for today. Now I'll take your leave, and just remember that, students, that on 4th, 5th, 11th and 12th scholarship is going on, right? You just have to give this test, and it's totally free of cost. Not even a single penny we are charging you for that. You just have to register yourself, and after registration, based on your results, if you're under 2.5 lakh students, you will get 100% scholarship on Vedantu courses, 150 crore worth of scholarship, 2 crore worth of cash prizes and rewards like iPhone, drones, iPads, all these things you will get for totally free of cost. But for that, firstly you have to register yourself, right, and then you have to give the test, right, on these dates, 4th, 5th, 11th and 12th, any date can be your test, right, and these are Saturday, Sunday only, so it will be easy for you to give the test, right? Okay, yes. Okay, yes, everybody, already in VLC, that's great, Vishal, awesome, right? So, our chemistry class really Wednesday, Thursday, Friday and Saturday, right? So, tomorrow we will have the class on the same time, that is 8 p.m. I'll see you here, right, with the same energy, same passion. We are going to do the next part of isomerism. Okay then, yes guys, I'll see you all in the next class. Till then, bye-bye, and don't forget to do your homework. I wait for your homework and I want you to do it, right? And everyone out there who likes that, okay, ma'am, you're teaching us, we're able to understand, appreciate us in the comment section so that we can also feel energetic and more motivated to teach you, right? Like this session, share this with your friends also, help them also, right? So sharing is caring, do that as well, right? Okay then guys, bye bye, take care, see you all in the next class, bye bye, see you all tomorrow at 8.